This lesson is on prime factorization and the greatest common factor. And it's a rather long set of notes, so you might want to get an extra sheet of paper ready to make your flip page. You should pause right now and get that. Your reference pages are pages 180 to 184 in the book. You probably remember prime numbers from like 6th grade or earlier, where you learned that prime numbers were numbers whose only factors were 1 and itself. Most prime numbers are odd. Actually, the only even one is 2. And 1 is not considered a prime or a positive number. A prime or a composite number. Composite numbers are positive integers greater than 1 that have had more than 2 factors. In other words, more than 1 and itself. It's got to have something else. So, prime factorization is about writing any composite number as a product of its primes. All right? So, we do that by what we call a factor tree. So here's an example. We're going to start with 72. Now I know that if I multiply 8 times 9, I can get 72. But 8 is not prime and 9 is not prime. So I have to keep working. So then I work them down to their primes. 9 is 3 times 3. Those are both prime numbers. 8 is 2 times 4. 2 is a prime, but 4 is not. But 4 is 2 times 2. So finally, I have all the numbers down to their primes. So if I'm going to write 72 in prime factorization, I'm going to write 2 cubed, because there are 3 2's, and times 3 squared, because there are 2 3's. That is how we do prime factorization. So it is simply breaking each number down until it is in its prime state and putting all of those primes together. Now we use prime factorization as a way to find the greatest common factor. And if you remember the greatest common factor, you probably learned that in 6th grade too, maybe earlier when you were doing fractions. And it's very important in fractions to be able to find the greatest common factor. And so the greatest means the largest, common means same, and a factor is a number that you can multiply times something to get another number. So the greatest number that you can find that they share. So there's 2 ways of finding the greatest common factor. You know, in the last section of notes, we factored numbers just by listing each of the factors that we could figure out. And we could list them like the factors of 12 are 1, 2, 3, 4, 6, and 12. And then the factors of 15 are 1, 3, and 5, and 15. And then we would simply choose the one that is the greatest that they have in common. They have in common 1 and 3, so therefore 3 is its greatest common factor. I always suggest that when you're doing this, you factor the smallest number first. That way, when you go to start factoring the other number, you could actually stop. We could have stopped at when we got to 5, 15 times 5, because if there were no smaller ones, there would be no greater numbers than that could be their factors. So you can always start with the smallest one. It makes it easier for you. So in method 2, though, we use prime factorization. So we took 12 and went 2 times 6, but 6 wasn't prime, so we did that again. 2 times 3 is 6, and now we're in primes, and we've got 2 squared times 3. 15, 3 times 5, they were both prime. Again, we see the only thing they have in common is 3. Let's look at another one. Let's do 40 and 60. So 40, we started with 2 times 20. But 2 is a prime number, but 4 was not a prime number. So we had to go 2 times 2. And 20 was 4 times 5. So now we know it's 2 cubed times 5. For 60, we did 3 times 20. 3 was a prime number, so we stopped there. 4 times 5 is 20. 5 is a prime number, but we needed to make 4 prime. 2 squared. So we got 2 squared times 3 times 5 for 20. There is only one prime number for any composite number. It doesn't matter how you start with it. I could have started with 6 times 10, and I would have still gotten 2 squared times 3 times 5 as the prime factorization. So when you go to find the greatest common factor, first factor each number, circle all the common factors, and then you use the least common factors and multiply them together. So 2 squared times 5. So it's a little different when you're doing finding the greatest common factor here. So we use 2 squared instead of 2/3. I mean 2 cubed, because this one doesn't have 2 cubed. Now let's look at ones that have variables. Let's see if I can get this up here. All right, so this is 14c squared and 35cd. So 14 factored down to 2 times 7 times c times c. 35 factored down to 5 times 7 times c times d. What they have in common is 7c. So therefore, its greatest common factor is 7c. Those are the notes on greatest common factor. I want you to turn over now and write on page 54. Do your check understanding on page 183, and you're going to do 1 through 16. And so turn off the video right now and complete that. It's probably going to take you a while. Really just think about and follow the rules, look at your notes, and then turn the video back on, and I will go through the answers with you. Okay, now we're going to go back through the answers on 183, 1 through 16, and it took me 2 pages to get this done, so I'll be showing you a second page when I get down to the bottom. The first section asks you to figure out whether the number is prime or a composite, and if it's composite, to write its prime factorization. One of the things that's really important here is this is where you can use your divisibility rules. If you have a number that's not a common factor that you know, like 27, you probably much are going to know 3 times 9 is 27. But when you get to some of those bigger numbers or numbers that you don't know, like 87, 93, then 53, you can use some of the rules of divisibility to help you solve the problems. So in the first one, we found that number 27 is a composite number, and it is 3 cubed. 3 times 9, and then 3 times 3 for 9, 3 cubed. 19 is a prime number. 1 plus 9 is 10, so it's not divisible by 3 or 9. It doesn't end in 0 or 5 or any of the even numbers, so it can't be divisible by any of those. So it's prime. 31 is also prime. Same thing. 3 plus 1 is 4. That's not divisible by 3 or 9. It doesn't end in 5. It's not an even number. It's prime. The next number, number 38, and there should be a 38 up here. It was an even number, so that's the first thing I did, was divided it evenly. And I found out that 2 went into 3 one time and then into 18 9 times. So it was 2 times 19, and I already know 19's prime, so that's its prime factorization. The next number, 45, is 3 squared times 5. And number 6, 53 is a prime number. 5 plus 3 is 8, so that kicks out 3 and 9. And you know the rules for the others. And then 87, I didn't know whether it was prime or not. So I added 8 and 7 and got 15. That told me immediately that 3 was one of its, it was not a prime number because it could be divided by 3. So I started with 3 and did 3 times 29. And 29 is a prime number. 2 plus 9 is 11. And it doesn't end in any of those even numbers or 5. So 29 was also prime. So it's 3 times 29. 93, I did the same thing. I knew immediately it was divisible by 3. And 3 times 31, and we knew 31 was prime earlier. Moving on to some of our bigger numbers, and I'll see if I can go all the way up on this page to show you the rest of this. Okay, yep, we got it in. I'll scoot it over a little bit later. Okay, 125, I knew that was divisible by 5, so I started with 5 times 25, and then 5 times 5, so 5 cubed. For 360, I started with 36 times 10 and had to keep working my factor tree till I got 2 cubed times 3 squared times 5. Number 11, now they begin to ask you to find the greatest common factor. And in each one of these, I use prime factorization to find it. I could have made a list of all the factors, but I wanted to practice my prime factorization, and it is usually the easiest way if you don't really know all of the factors. So the prime factorization for 45 was 3 squared times 5. So I did 3 times 3 times 5. And for 10, 2 times 5. So the only thing they had in common was 1, 5. So the greatest common factor was 5. In number 12, they asked for 3 numbers, 2 times 3 for 6, 2 times 2 times 2 for 8, and 2 times 2 times 3 for 12. But the only thing they had in common was 1, 2 each. So 2 is its greatest common factor. In 13, we looked at 42 and 65. And if you notice, by the time we factored down, we got 2 times 3 times 7 and 5 times 13. So its greatest common factor is actually 1. Okay? Neither one of those numbers is prime numbers, but they don't have anything in common. So 1 would be the only thing they had in common. When you use variables, you have to write out the variables as well. So this was 14c squared, so I wrote 2 times 7 times c, and this is 35c, so I wrote 5 times 7 times c, and what they each had in common was a 7 and a c, so the greatest common factor would be 7c, whatever that is. Bringing in the next part, on number 15, we got to do variables again. It was 3y squared and 24y to the third. So 3 was 1 times 3 times y times y. 24 was 2 times 2 times 2 times 3 times y times y times y. What they had in common was a 3 and 2 y's, so their greatest common factor is 3y squared. Now, the question it asked you was, it said that one student started with 3 and one student started with 5. Will they get the same answer? And the answer is, of course, yes, they will get the same answer. And the answer, of course, on this is no, because there is only one prime factorization for each number. So it doesn't matter how you start, you'll still end up in the same place. So I did the example so you could see it. We started here with 3 times 75. 3 was prime. 75 was 5 times 15. And then that divided into 3 times 5. And so we got 3 squared, 5 squared. But over here they started the same number. They did 5 times 45. Looking at it ending in 5, deciding 5 worked, instead of adding them up to find out that 3 would work. So 5 times 9 is 45, so we've got our 2 5s there, and then 9 is 3 times 3. So again, 3 squared, 5 squared, times 5 squared. It doesn't matter how you start. You can start with any number it's divisible by. Its prime factorization is going to come out to be exactly the same. All right, that completes that lesson. You'll be doing in class tomorrow page 183 and 184, 17 through 47 odd, and 54 through 57 all, which is the review part of the lesson. And if you have any questions on prime factorization, please come and talk to me. Or there was a video you got to watch before you took your notes. Hopefully that was helpful as well. You can review that video, and but you can also come and ask me questions. So we'll see you in class tomorrow.